Hey everyone, welcome back to my video series on how to make a Pokemon style game. In this video, we're going to set up a level manager that will keep track of the Pokemon that we are losing, the Pokemon that we are capturing, so that we can figure out when we've won or lost the game. Let's get to it. Alright, so let's start with creating a C# script, and we can call this script level manager because it's going to contain the level manager class that we're going to use to keep track of everything. So once Unity is done loading, we can also create an empty game object that we're going to call level space manager, like so. Note the space in between. I'm doing this because we're going to use the term level manager a lot of times, but the capitalizations and whether there's a space or not, it's going to refer to different things, making it a little bit easier to keep track of what is what. Anyways, we're going to add a component to it, just a script, and it's the level manager script that we want, which is already preloaded. So that is great. Now, what I like to do is I like to put these at a very easy to find position. So I'm going to put it at 0, 0, 0. And I've done this as well for the global volume, which I put at 0, 50, 0. So that keeps it out of the way of stuff as we are working on this. I'm going to put this one at 0, 55, 0. So it's just floating above that global volume, which I think is for post-processing and lighting. But anyways, so here it is now. And to make it a little bit more easy to see, we can give it an icon if we want, or we can just give it a little color. And now it'll look like level manager and we can actually see it. All right, so let's have a look at that class that we just made. And I'm just going to move my things down here a little bit. And we have a new level manager class in Writer, and we can use this, and well, we'll see if we end up using a start and an update as we move along. But we're going to start with the big purpose of what this level manager is going to be doing, and it is going to keep track of the amount of Pokemon that are in our map. So that's one thing that we're going to be doing. We probably also want to keep track of the amount of starting Pokemon that we're going to have in our map. Because, well, these, at some point we want to know how many Pokemon we capture. So that's going to be the difference between the amount that's left and the amount of Pokemon that we had originally. And we can make those private to the level manager for now. And they can be integers because there's never going to be a half Pokemon in this game, which all should make a bit of sense, I would say. So to start things off then, let's give these variables some content. So amount of Pokemon, pretty easy to figure that out. We can do game object dot find game, here we go, with tag, and we are looking for the tag Pokemon, which we have already set up already for the collision. But what we are going to get as an output here using this method is a where can I see it? It is going to be an array, which you can see based off of the brackets, so a list if you will, but it's not actually a list because a list is a different thing in C#, but it's going to be an array of strings that we're going to get. So we can use a method to get the amount of items that are going to be in that array, and in this case, it's actually a property for that. So it's just dot length. So game object find all objects with tag. We'll put an array out, and when we get length for it, that will be the amount of items with that tag. So in this case, amount of Pokemon. So that's pretty straightforward. And at that point, what will be our starting amount of Pokemon? Well, when we are running this in the start method, it's going to be literally the same thing. So when the game starts, both the amount of Pokemon and the starting amount of Pokemon are going to be the same. So that's pretty convenient. Moving on then, we want to create a method, and this is going to be a public method. It's not going to output anything, but it needs to be public because we want to access it from a lot of different places, and it's going to be called removePokemon. We are going to give it a parameter, an argument coming in for the Pokemon that we want to remove from the game, and then as well a Boolean that we're going to call capture, which we're going to use to pass on to this method whether or not the Pokemon was captured by a Pokeball or if it left the map because it was digging. So when the Boolean is true, it was captured by the Pokeball. So with all that, we want to destroy the incoming Pokemon game object when this triggers. And we also want to remove the amount of Pokemon by 1. So minus minus. And while we're at it, we might as well write a little condition here as well. If that amount of Pokemon will ever be equal to 0, or just for, I don't know, if there's a bug or something, if it's smaller than if it's smaller than 0, which probably will never happen, trigger this as well. And We'll put some code in there later on, but end the game when we are there. And I think this is a fine method for when our Pokemon gets removed. So what we want to do now is replace all our instances of destroying a Pokemon with the remove Pokemon and this logic here. So let's get to that. And the first instance that we are going to adjust for that is the Pokeball controller, where we are destroying a Pokemon when we got to case 6. So now instead of using this code, we're actually going to access our level manager and remove the Pokemon using the method we just made. So first things first, we want to make sure that we grab that level manager. Now, we could make this a public one and hook up the level manager. I've been doing that for a couple of videos now. I don't know if the last video I was still doing this, but in this case, I'm actually going to go with a private level manager. So level manager is going to refer to the class that we just made in the script that we just made. And I think we can just call it level manager, should be fine. There we go. Just call it level manager. And then in start, we're going to grab that level manager. So level manager is going to be equal to, let's see here, game object dot find. And here we are using the name that we have in the editor for the game object that's actually in the scene. And then we can use get component to grab a level manager class that is attached to it. Oops. There we go. So many typos today. And yeah, so that will hook up the level manager to this script so that looking back down here, there we go, where we're going to destroy the Pokemon, we can now actually access the script that we made called level manager, and we should see remove Pokemon pop up. Now, if you don't see remove Pokemon pop up there, that is probably because you didn't set the method to public. So it has to be public for this to happen. Private function is not gonna, or private method is not gonna pop up otherwise. What do we want to input here? We want the Pokemon. We want to pass on the Pokemon game object that we're destroying, and well, we're doing it all the time in this script. Every time when we're referring to the Pokemon, we are using Pokemon as a variable, so this will work just fine. And is this Pokemon captured or not? Yes, this Pokemon is captured. We're going to set that to true. So this should remove our Pokemon again, and everything should work in pretty much the exact same way, except now we are keeping track of the Pokemons that are being removed. Wonderful. So let's go to the second script then, where we're removing Pokemon, and let's see, the one where we are going to check for dig, I think, or dig completed. That's the one where we're destroying the Pokemon as well. Now this is the Pokemon controller, so in this case it's not destroy Pokemon, it's destroy the game object, which is the Pokemon itself. So here we can do the exact same thing again. We're gonna have to go to the top of the page again and set up our level manager. So let's do that real quick. Oops. Oh, geez. Private level manager. Ooh. Level manager. Oh. So you really want to be careful when you're using Writer and you're just pressing tab to figure all these things out a little bit faster, because it's easy to put an uppercase character where there should be a lowercase and everything will go wrong. But our level manager is going to be equal to game object find level manager. So here it's capitalized with a space in between because this is the object that we have in the in the scene. And then get component level manager with uppercase L, uppercase M, and that should hook it up to what we need. And then in the structure we can go to check for dig. Keep forgetting it's actually dig completed. And here we can do level manager dot remove Pokemon. What are we putting in this time? Not Pokemon. We're putting in the game object. We're putting in ourselves. And this is going to be false because this Pokemon is not being captured. They're actually being removed from the game. So doing this should lead to the similar outcome that we saw earlier. And in our Pokeball controller, we want to go to the part of our state machine, I think case 6 or 5 rather, where we are checking to see if our Pokemon is escaping or not. Now, first off, there seems to be an issue here. This needs to be an integer instead of a float, because we want the random range to be whole numbers 1, 2, 3, 4, up to 10, right? That's going to come out of this. It's not going to matter that much because since we are not writing F here, these are registering as both integers. So the random range function is probably going to output integers anyways, but our R is a float, so it's just not correct. If these would be floats like so, it would be inputting all the various numbers with decimals in between 1 and 10. So 1.1, 1.2, 1.3, and even worse, 1.11, 1.111, and so forth. So we don't want that. We want the maximum amount of numbers to come out of this to be 10 whole numbers, right? So let's not do that. But anyways, it's a minor issue because it doesn't change the logic, I think, turning this into a float, but it is incorrect, and R needs to be an integer, not a float. Anyways, what we want now is for this to never happen while we are testing our game. So to make sure that this never happens, instead we are going to write if, well, we could just write false, honestly. Well, we need to put false in between, like so. And what you'll see is that writers immediately like, hey, that code's never going to happen because this is always going to be false. I'm like, yes, that's exactly what I want. And this makes it pretty easy to set it back the way we want it. So now every time when we toss a ball into the Pokemon is going to be captured, which is going to be super helpful for us to test our code. All right, let's get back to the game. All right, I'm back in the Pokemon game. Let's see if I can hit him on the first attempt. Yes. All right, so the code is going to make sure that he always gets deleted. And let's see if up here, yep, we went from inactive to delete. So that worked. I'm not going to test the other function more extensively. I'll do that some other time. But it looks like our code is doing just fine. So that means we can get back to our logic for when we're ready to end the game and move on from there. So let's see here. First thing that I want to do is, because I just realized as I was testing this, I don't really have a variable to keep track of the amount of Pokemon we've actually caught. So this is just the amount of Pokemon in the level at any given time. And this is the starting amount of Pokemon. So let's make another one here. And let's do private int amount of Pokemon caught. There we go. And that's going to be a different variable from what we have in here at this point anyway. So whenever we capture a Pokemon, so if capture is true, we can do amount of Pokemon caught ++. And that's going to be a better way to keep track of the amount of Pokemon that we've actually caught, because we could, we can't just take the starting Pokemon and then subtract the amount of Pokemon to get this number, because sometimes Pokemon will escape. Probably not going to happen a lot, but it might happen every once in a while. So that's one thing to keep in mind for whenever we capture. We want to have that a separate variable keeping track of that. So with that in mind, we can put some logic in here for our end game and for communicating to the player. Now, I'm not going to implement a full graphical user interface just yet. We'll just use some log messages. And the first ones are going to come for the end game. Let's do that first. Now, to end the game, we are going to implement both a timer. So there's two ways the game could end, right? It's either there are no more Pokemon in the map. So that's what we have here already. And the other one is we run out of time. So let's set up a timer. And since we are going to have a graphical user interface eventually, we want these variables to be public so we can access them that way, so that all our information regarding to the level of the game is in the level manager. So what we're going to do here is a public float called current time. And then we're going to do a public float called end time. Okay, and we are going to set end time in our start method, and we're going to set end time to maybe like 15 seconds maybe for now. I think that would be fine. And then in our update method, we're going to keep track of end time. Now there's, there is the time class, which does have a property called, I believe, fixed time, as you can see here, that will track the time since the start of the game. However, we can't use this. We're going to have to keep track of it ourselves, because this, if we restart the level, this will still add all the time spent in the previous iteration of the level as well. So we do need to keep track of it ourselves, and we can do that pretty easily, honestly. All we have to do is current time equal to the time class is delta time, which is the time in between two frames. So if we add up all the times between the frames, we get the time that the game is at any given time. And then if our current time is larger or equal to our end time, current time, yep, we are going to end our game as well. So let's say we have a method called endGame, specifically for that purpose. Endgame, and we can use that method here as well. So 2 times endgame, lovely, lovely, lovely. How about we declare that method? So it's going to be public void endgame. And what do we want to do when we actually end a game? Well, one, we want to pause the game. So we can do time. The time class is timescale property, and if we set that to 0, that means that our game's going to be paused. Now, whenever I pause a game at any, whenever I develop a game, I always go to the start of the game, which is going to be somewhat here. I mean, it's not literally the start, but at the beginning of the game, and I'm going to make sure that I set the timescale to 1 already, because this is going to save time debugging when sometimes the game will just freeze when we're programming restarting the game, which we will do at some point. What I also think we should do at this point is make sure that we give the player access to the cursor again. So we're going to go to cursor mode dot, let's see, no, actually it's cursor dot lock state. Yep. And that's because cursor mode is the enumerator that is associated with it. So we want cursor lock mode none. So this will give the player access back to the cursor lock state. Now we're getting into this end game and we're doing all that kind of stuff. And for now, since we're not using a graphical user interface, I'm just going to use the console log to write a message to the player on what is going on. So at this point, the game is ended. Let's make this a very positive game. Well done. No matter if it's positive or negative. Let's just do well done. You have captured, and then we have captured, what is it? Amount of Pokemon caught. All right. So, and they're all PsyDucks, so we might as well call them out. You've captured this many PsyDucks. And then maybe add why the game is ending. So maybe before they all run out or before time ran out. So let's do the reason. Let's make that a string variable right here called reason. There we go. So you have captured the amount of PsyDucks with a reason. And then we, in end game, we can add the reason to it, or actually we might as well just input the string. So yeah, I was thinking something like, so here we're running, so let's see, before they ran out, or before they all escaped. Let's do that. Before they all escaped. Because you could have Pokemon escape, and that's why we don't have any more Pokemon on the map. So before they all escaped, you might have got all of them, which is the same number, or less of them. And we could, we could use the starting amount of Pokemon to track, but like I don't want to put any more information in there. And this one here is going to be, you caught this many before time ran out. So it's not really like, oh no, game over and this happened. It's just like a very positive little game. And I think we all need happy little games these days. So let's do that. For when we capture, I mean, I'm going to send a message to the GUI and just communicate with nice typography to the player what's going on. But for now, we can just use a lock debug message. And we're going to write here, let's see, capture. So this means success. You captured a PsyDuck. Huzzah! Now, if that Boolean, oops, oh dear, here. So if that was not true, so else, it's going to be like, whoops, whoops, a PsyDuck escaped. Let's use that instead. All right, so I think this should be, pretty solid. So we have a timer now that we're not communicating just yet. I mean, we could do a logger to see if the timer works. Why not? So let's log and just literally write current time in here. It's gonna be pretty busy. But yeah, let's see if this stuff is working. Or wait, no. You can't put this in the start method. It'll just be like time is 0. Let's put it here in the update method, so it will run and trigger every frame, because then we can actually see something happen, hopefully. All right, we're getting a warning here because we have the unreachable code, which I think is super cool. And let's press play, and let's see what we get. So yeah, we're gonna see time just get updated the entire time, and let's try to hit my Pokemon. Oh no, he ran away. Oh dear. So now I'm going to have to go find him again. But at least time is running, and once we hit 15, Yep, well done. You captured 0 Pokemon before time ran out. That's amazing. Super. Aren't we amazing? All right, so yeah, I'm going to test this a couple more times. You should probably test it as well. But I think this code is fine and we can move on. Okay, so after some more testing, I think the only thing I want to change right now is this little bit of code where I would like to make sure that the language is a little bit better. So if the amount of Pokemon caught is literally 1, then we are going to make sure that we have 1 PsyDuck in our message, and otherwise we can have PsyDucks. So if it's 0 PsyDucks, that's still proper English, I think, right? Okay, so yeah, that's a quick update that I wanted to do here. And I think for this video, there's another thing that I want to attach to it, which is less to do with the level manager, but I think I want to start with making another scene real quick so that we can load in and load out another scene when we get towards the end of the game eventually, which is going to involve a little bit of user interface toolkit type of work. So let's get to that. Now, to do that, I'm going to have to go back to Unity, but first I think I want to make sure that that warning goes away. So instead of if false, we can set this back to, oh, yeah, I shouldn't remove. There we go. In our Pokeball controller in case 5, we're going to put this back so that our Pokemon will sometimes escape. There's a 1 in 10 chance that they'll escape, and you can change that number to make the game play however you like your game to be played. And with that, we can go to the Unity editor again. And then here we are going to go to our scenes and we are going to create a new scene. So let's see, where is the scene option here? Right there. There we go. And we are going to call this scene the very uninspired name Start, because this is going to be our start scene. And when we double click it, it's going to ask us to save our sample scene. We should have called this game at some point, but now I don't really want to mess with it anymore because there's a folder and I don't know if Unity will update all those things. So whatever. So what we have here is just going to be an empty scene. We don't need a directional light in it. I think a main camera is still going to be needed, but a light it's not, because this is just going to be an empty scene for us to put a UI document in pretty much. So how does that work? So Unity actually has a couple of options if you look at the manual for creating user interfaces, the UI Toolkit, the Unity UI package for UGUI, and IMGUI. Now, these are for different use cases, basically, and the Unity user interface is what people have been using for ever since Unity was there, I think. This is their older, outdated system. UI Toolkit is a newer system that is based on web standards. So if you're familiar with cascading style sheets, CSS, and XML and stuff like that, this actually will look very similar in a lot of ways. And then there's the immediate mode graphical user interface, which is entirely code-driven. So we are going to go with the Unity UI Toolkit because this is actually what Unity recommends themselves. And it has a lot of really cool features, honestly, that are going to be super helpful for what you want to do. So if you want to look at when do you want to use Unity Toolkit versus Unity UI, it's basically at this point, you recommend whenever you want something that's lit in a 3D world, you can go back to the old Unity UI. But if you're using something that is going to be a 2-image across your game scene, the UI Toolkit is the way to go. And if you want to program everything from scratch, there is the other option, the IMGUI. Anyways, let's move on to Unity and implement something with UI Toolkit. And the easiest way to do this is just click on plus and then UI Toolkit, UI document. And this takes a second because something's going to start loading any second now, usually. That's kind of how it's been for me, but right now it doesn't seem to be loading, so I guess we're good to go. So our UI document, in this case, we're just going to call it our menu, really, because it's not going to do a whole lot. And then it will have created this folder called UI Toolkit, in which we will find panel settings and Unity themes. So it comes with a game object that we can reference, and then in here, you basically make your pages. Now, for that game object, it will have this UI document that needs to be connected to a panel settings, but Unity has already done that for us. And then a source asset, which is basically the page, if you will, the menu, the user interface asset, really the visual thing that you're going to attach to it. So let's create one here. Let's right click in there and then create UI Toolkit, and let's create a UI document. And this is probably where it will load for a second. Oh, okay. So I thought that this was happening when I would make it here, but apparently it happens down there. So then you get a new Unity XML template file, and we can call that whatever we want. In this case, I think just call it start menu or something like that. It really doesn't have to be much. It's telling me that there seems to be a meta, I think that's probably related to my computer. If it's not, let me know. I'm curious to figure out why that's actually the case. But when we double click this now, it's going to open a UI builder window. And I'm going to drag that out and I'm going to put it next to my animator because that's where I like to put it. Because, yeah, I want to be able to edit this pretty easily. Now, you know, similar to, like, I'm working on 1080p for the video, so usually in 4K this is a lot bigger, but it should work just fine. So what you will find in here is similar to if you worked in other game engines, like Unreal Engine has UMGs. Like it's basically trying to mimic a web building type of interface. So anyways, kind of like what cascading style sheets would do if you're familiar with that. So let's click on our hierarchy here, and this is our root. And what we can do now is we can have it match our game view. And I'm using my middle mouse to zoom in and out. I'm just scaling this a little bit to get everything kind of a little bit in view. Boy, all right, not that much space in 1080p. I hope you guys have a higher resolution monitor for this. Yeah, it's throwing up some strange exceptions. You know, this is relatively new addition to Unity, I think. So it's just doing weird stuff sometimes, but it'll work fine if you follow along. Okay, so then in our root, we can set a canvas background and we can set it to all sorts of things. We can give it a color. We can put an image in there. Well, we have to enable it first, a color, an image, or we can even set it to a camera, such as our main camera, which will have our game view come through this. Now, for the purpose of what we're going to do, we don't need a game view at all, and we can just leave this canvas as is, just uncheck it. The only thing you want to do is have it match the game view, so it will scale alongside the resolution of our game, which in this case is oftentimes going to be 1080p, but if you're on different devices, you'll see different things. Up here, you can also set it to the runtime theme, so then you'll see what it's actually showing. So right now, whatever's in here is going to be transparent, so that's all right. And then up here, we'll have our library, and you can, I'm just going to have to, you know what, since 1080p is so small, I'm going to drag it up in the top and drag this down, and that'll give us a little bit of extra space. Yeah, things you got to do when you're making a video. But here you have all the containers and all the things that you can drop in your hierarchy as you're building up your menu. And what we are going to do is we're just going to drop an image in here, and I'm going to provide you with an image if you're in my class through the class site, and a font as well that we're going to load into Unity. So let's do that first. So the font that we'll be using is called Lemon Days by Kurasan, and you can download it for free from thefont.com. For my convenience, I already put it on my desktop here. So let's bring this into Unity, and I'm going to make a folder for that in the UI Toolkit folder that I'm going to call, where is it? Folder, here we go. I'm just going to call this fonts. It's only going to be one font. Open it up, and then in the folder that comes with the font as you download it, I'm just going to grab, you could get the TrueType font or the OpenType font. I'm just going to go with the OpenType font. I don't know if that would actually make a lot of difference, but that's what I'm going to do. And if you click on the font, then one thing that you need to do whenever you import fonts into Unity is you want to run this script on them. And to do that, you can right-click the font, click on Create Text Font Asset. And then it will create this SDF for your font that we were going to need later on as well. And again, Unity is calling all these weird warnings that are not really seem to be doing much to get in the way of me creating this game for some reason. So anyways, there's a lot of additional information about the font as it's been imported as an SDF into Unity. We're not going to worry too much about that right now, but just so you know, it's right there in the inspector. All right, so we've got that now. Let's bring in that image. So we could drop that into textures, or we can just make a folder here and we can just call it images and open that up. And this one I'll provide through the class website as well. And it's just a really cool title screen that we can use. Okay, so now that we have all our assets in here, we can start adding them to it. And for the image, that's going to be the first thing that I'd like to do. We're going to create a visual element. So just drag and drop it in there. And a visual element is, it's kind of similar to making websites. It will scale and stretch and grow in ways depending on the content that's in there and depending on where you pretty much attach the different anchors of the element to. So in this case, we are having a visual element here, and all we really have to do is make sure that this thing is just as big as the entire page. So I'm going to select it, and here you'll see inline styles. Now, if you're more familiar with CSS, you could actually make style sheets up here. That's not something I'm going to cover for this specific project because it's too small to really worry about that. But what we can do is we can use flex boxes, and a flex box is a way to pretty much organize the content that you're having on screen. For more information, I'll provide a link on that. But if we set our flex to grow, as you can see here, our visual element will grow with however big our scene is. And as we're moving this around, this will start changing every once in a while when we press play as well, because now it's still hooked on the resolution that we had originally. So anyways, we set the grow to 1, and that will have our menu stretch out with the rest of the screen, which is great. So then we're going to go to the background of the menu, and we can select an image texture here. So if we grab the title screen, drop it into image, now we have our visual element displaying PsyDuck hunt, which looks pretty cool. And if we press play now, so let's go to scene first, and we press play, let's see what happens. Absolutely nothing. But that's not too surprising, actually, because we haven't hooked it up to a game object yet. So what we need to do is select our menu, and our source asset, we need to connect this to that start menu that we just created. And if we press play now, I'm going to save first and then press play, we should see, we should see our screen pop up as such. So that is what we want. Now, to wrap this video up, I'm going to put a little bit of text somewhere here that will tell press any key to load the actual game. So let's do that. Going back to the UI builder for that. And then in here in our hierarchy, we have this visual element. We haven't even given it a name because I don't think we're ever gonna need code to address this thing. And as you can see, I don't know if this is noticeable for you, but the resolution has changed. Like, it used to be less high because I have been moving around my scene as we were looking at the game as such. And the UI builder, as soon as you press play, will adjust its resolution as well. Anyways, what we want to do next is we want to add a label. So a label is basically just text, like so. And this is a label that we're going to make it blink, because most games do that. So what we're going to do is we're going to add a name to that label, and I'm going to call it call to action. It's not really a button. It's just like, hey, can you press any key for something to happen? The text for that label is going to be press any key to play. Since Lemon Days, the font that we're going to be using is all capitalized. It doesn't even matter which letters you capitalize or not. So let's get back to this thing here. And I think that covers all of this stuff. Now, if you zoom in, you'll see that it's already right up here in the upper right corner. So the first thing that we want to do is we want to move that to the middle of the page. So to do that, we can grab the parent class or object or element in here, which is a visible element, and that can control the alignment of whatever is in there. So if we align this to the middle, it will align everything in there to the middle. And we can then also set it to the bottom of the page, so it'll go down there using the align functions. All right, so then go to call to action, and then the position, because we want to move it up a little bit. And for positioning, you can put it down absolute, so then it will be tied specifically to the spot where it's anchored, or you can set it to relative. I'm just gonna unset this, but to relative, which means that you can enter percentages, and it's gonna be all relative to its bounding box. So in this case, relative is absolutely fine, and we're gonna use a percentage of, like, I don't know, 10% or something. That looks a little bit high. Let's set it maybe to like 3%. There you go. That's kind of where I would want it. And yeah, let's make the text look a little better. So let's open this thing up here. And here we can make changes to how our text is rendered. And We can make some edits to this. I mean, it's going to be quite a bit. So we want to make this look a little bit better. Now, the first thing we want to do is make our text kind of scale in between here. And we can set the text relative with a percentage, or we can just use the pixels. Now, one thing that you're going to notice is there might be some scaling issues. So let's say I set my text to something like maybe 42. Well, let's set the font first, actually. So the font Lemon Days, and then Lemon Days SDF. And yeah, maybe like 56 would be a good size. Yeah, I like that size. That looks good to me. Now, the issue is if we keep stuff the way we have it right now, and we're going to play the game, it should look fine. So let's just go to play and see what happens. But yeah, this is already different from what I just saw in my UI builder, because my UI builder updated itself to that resolution. So it's not very consistent, the way the text is going to be portrayed in this kind of way. And to fix that, we need to do something else. So let's pause our game here, and we're going to go to our panel settings, and we're going to set this to scale with screen size. And the reference resolution that we're going to use for that is going to be 1920 by 1080, which is a standard resolution. And we're going to use that for this specific game. But so we're basically just going to keep scaling the game as such. This is probably something that'll get sorted out as the UI Toolkit becomes more mature within Unity, but this is a way to make sure that your text will at least look the same on every screen that you play this game on for now, which I think is fine. If you want to have other options, you can use the older system again, and that will give you other opportunities. All right, so then we can set the colors for this. So I think I want to have a yellow, and what I like to do is just, get something that looks all right, like maybe FFCC00, that's a broken yellow. So a little graphic design tip, like if you take a broken color, it's typically prettier. We don't need an outline or anything. Maybe having a bit of a text shadow would be helpful to make it a little bit easier to see. So let's say we go here, let's do something like maybe 0022FF. That's a little brighter than what I would like. Let's bring it down to, maybe like 55. Yeah, I like that. Or let's do 77. There we go. 002277 for the blue. And we're not really going to see that color in here yet because our text shadow is right behind it. So if we move 3 pixels. And I've noticed that, the toolkit is doing weird things here still. So I'm just going to set this. Yeah, it's set to default Unity runtime. So this is actually going to pop up blue if we actually play the game. So let's go back to our scene and click on play. And yeah, so as you can see, it's actually popping up blue. And this text is pretty much looking the way we want it to look. So that's pretty neat. And I don't think we have to make any additional changes for now. Just let's turn this off real briefly, go back to the UI builder and make sure that we have a name here, call to action, because we're going to refer to this name to make this blink with a quick little coroutine. So let's go do that and get into our project folder and create a new C# script. And this one can be called Start Screen, Manager, Controller, whatever you want to call it. Let's go into Writer and add some code to it. And we only need 2 things for now. So we are going to first create a private visual element that we're going to call root. And then we're going to create a private label that we're going to call to action. Now, these classes refer to the classes that we just used within the UI builder. And we're going to use them to grab the elements. So root is going to be get component, and the component is going to be a UI document that we have, .root visual element. And this really is the code that you need to use to just grab the tree, the hierarchy really, of whatever you build in UI builder. Next up, our call to action is going to be root, and then we're gonna use the letter Q, which just stands for query really. And we're going to look for a label, and we're looking for a label. So this is pretty much like GameObject.find, a label called call to action. Okay, like so. And yeah, I think, let's see, what else do we need to do here? So we want this label to start blinking, right? So to do that, we are going to make a coroutine, and that coroutine, we're going to call it, let's see, I think we're going to use update later on as well, but the coroutine is going to be blink call to action. So we're not actually setting it up as a coroutine. We'll use the invoke. This is just easier, and this is just something that is going to be pretty simple in terms of code. So all these items have visible as one of their properties, so we can use call to action visible equals to whatever it is not at that given time to just toggle the visibility, and that's really the method that we want to run. And we want to run that method about every 0.25 seconds or something should be a good blinking. So we're going to invoke repeating from the start so that we don't have to manage, at every frame. And we can go with blink call to action as the name of the method that we want to invoke. And repeat will have two parameters. The first one is the time that you first want to play it, and then you want to have the repeat rate, so every 0.25 frames. Or seconds, I believe, as well. So yeah, that should have our, so that should get our item to blink. Now, before we go test that, I'm going to, I hate that these things just are in there, but in void update, let's also do a if input.anyKey, which you might remember from this previous video where we were working with this kind of stuff. If we do that, we can actually maybe go play the game. So let's do the SceneManager. Now, SceneManager is something, it's a namespace that you need to add, I think. So when you type this in, or maybe not. Okay, so SceneManager load, is it load scene? Yeah, I think it's load scene. So load scene, and then you just have to put the path into whatever you want to load. So in this case, scene, sample scene. There we go. And yeah, that should do it. So yeah, you can see that Rider already did this for us. So you're not using Rider, you need to add Unity Engine Scene Management for SceneManager to be available. But Rider took care of that. And this is pretty much the entire script. The only other thing that we need to add is, if you remember, at the end of the game, we're going to set the time scale to 0. So it's a great idea to, at this point, set the time scale to 1. We don't need it the first time that we're running this, but if we're going to come here from after playing the game, we want to make sure that time scale is running again, because otherwise our animation is not going to work. And I don't think we can actually do input that way. Maybe we can, who knows. But yeah, so this looks like a fine script that should load what we want to load. So then I'm going to go back into my PsyDuck game. Enumeration. So this looks like one of the errors I'm getting from the UI builder. Hopefully these are, maybe when you watch this video, it has been getting its updates and this is no longer an issue. So yeah, in the console, I'm going to clear out all of these. I'm going to press play, see what happens. So this is a little bit more of an experimental video, I guess. So let's see. Press any key to play is not really blinking. And if we click anywhere, nothing is happening either. Why is this? Well, obvious. We never connected our start screen manager to anything. So what we're going to do is we're going to go to the menu, go to, let's see if we can find it, start screen manager, add that script like so, and then press play again. All right, so now we have the blinking going on perfectly. And when we click, we end up in here. Now there is one issue that I'm noticing that you might not like. Well, for one, as we moved around, our cursor became active, but to make that go away, you just have to click somewhere in the editor. But our shadows are really, really harsh. Oh, we ran out of time. So there is a little bit of an issue here going from one to another scene. And the reason why is because we've never built lighting in that scene. So I think that's the last thing that I'm going to do to make sure that we have a good transition here. So I am going to take care of the baked lighting. And to do that, all we have to do is go to Window, Rendering Lighting, and the menu opened up on my secondary monitor. So give me a second while I pull it over. And if we go to the baked light maps, you'll see that there is no lighting data asset available for this level. So all we have to do is generate the lighting so that there is a file for baked lighting, which will soften the shadows a little bit. So the baked lighting is basically lighting that you have calculated before the game is started. It's already there. So this allows for players not having to recalculate lighting over and over and over, and only the lights that are actually dynamic, that are going to change while you're playing the game, are going to be recalculated. So it's an optimization type of thing. So I'm going to go to my sample scene as well now. It's lovely how quick Unity is in actually loading these. Unreal, it takes a little bit longer. And go here, click on generate lighting as well. And this is going to take a little bit longer because it's going to have to calculate the light maps for a lot more stuff in the level. So I'm going to let it do that. You'll see that it will do stuff in your scene. You know, if you have a very, very big game, this could be something that you want to do while you're sleeping. I don't think it's going to take that long here. Because this is not a very, very big game at all. And oh, actually, I think we already completed. Yeah, like, so this is what it looks like, our light map. So great, I think we can close this now. And just to make sure that this is working, we want to go back to our start, save, and press play here. And if we run the game now and go to, yep, see, now our lighting looks the way it's supposed to. So that's great. I said I was going to end here, but like there's one more thing I want to do real quick as well, and go in build settings, build this up. And what we want to do is add open scenes to it so that our start is in here as well. And then we want to make sure that sample scene is the second scene that we load, so that the game will start on the start menu whenever we build it. Now, what I would typically recommend that you do, and I haven't done this consistently because this is like an introduction to Unity, really. But whenever you're working on a game and you have a major milestone, build your game, see if there are any major errors, because there might be, and you want to avoid that. So, you know, this might be a good time to see if you can build the game, and if there are any issues, you can take care of those. I'm not going to do that right now, though, but it's just a bit of advice when you're working on a bigger project than this one. All right, now a final thing that is kind of bugging me, that has been bugging me for a really long time, and I'm sure some of you watching this have thought that was really annoying as well. That little dance thing that the character does, especially now that we're going from the menu into this, it's really annoying. So I just want to take care of that. So easy way to take care of that is select the character, go to position. Oh, actually, no, player game. That's how we want to do it. So the reason why that happens is because the positioning isn't perfect, and it needs to be absolutely perfect. So what we can do here is we can go to our trainer, make sure the trainer selected, click in position, click copy this, so that we have the position absolutely perfectly. And then we can stop playing the game, and we can go to position, and we can click paste. And this will change the position of our character a little bit. And when we press play now, it's fixed. So great. All right, so yeah, I think that works out for now, and that should suffice for this video. I'm gonna put this together and render it out, and in the next video, we are going to, what are we gonna do? We're gonna make a GUI. Yeah, we're going to put all that text that we have in the logger right now, put that on screen, make it look good, maybe put a little timer in the upper right corner, and yeah, our game is gonna feel a lot more like a game that way. See you there, bye-bye.